in the silent, eternal vacuum of space. 13 billion light-years from Earth, something truly inexplicable is staring back at us. The James Webb Space Telescope has pierced the veil deeper into the cosmic abyss than any instrument before it. And what it found defies the very foundation of physics we thought we understood. It has discovered titanic, primeval galaxies that shouldn't exist, black holes older than time itself, and eerie whispers from rogue worlds screaming across the void. Here at Stellify Science, we journey into the universe's darkest secrets. If you're ready to have your view of reality change forever, make sure you hit that like button and subscribe for more mind-bending discoveries. Prepare yourselves. We begin. The Hubble tension. Something is terribly wrong with the universe. For decades, scientists confidently believed they understood how fast our cosmos was expanding. The Hubble Space Telescope gave us one measurement, and mathematical models predicted another. Everything seemed to fit together like pieces of a cosmic puzzle. Then James Webb looked deeper than anyone had ever looked before, and the puzzle exploded into 1,000 fragments. The universe is expanding at two completely different speeds, depending on where you measure it. Think of it like a balloon being inflated, but the top half stretches twice as fast as the bottom half. This should be impossible. The laws of physics rigidly demand that expansion happens uniformly across all of space. Webb confirmed what astronomers secretly feared most. When they measured the expansion rate using distant stars called Cepheid variables, they got one number. When they calculated it using the cosmic microwave background radiation, they got a completely different one. The difference isn't small. We're talking about a discrepancy so massive that it suggests our fundamental understanding of reality is dangerously wrong. Scientists call this the Hubble tension, but that name doesn't capture the true horror of what we're dealing with. After studying over 1,000 Cepheid stars across 5 separate galaxies, stretching 130 million light-year into space, the contradiction remains. The implications are staggering. Either our models of how the universe works are completely broken, or there's some unknown force tearing reality apart. Adam Ree, the lead researcher who discovered this crisis, put it bluntly, with measurement errors ruled out. What remains is the real and exciting possibility that we have fundamentally misunderstood the universe. The word exciting feels wrong when you consider what this truly means. If our basic understanding of cosmic expansion is incorrect, then our calculations about the universe's age, size, and ultimate fate are all suspect. Webb's unprecedented precision has removed any doubt. Universe breakers. As the telescope continued its survey, it began finding objects that shouldn't exist. 6 impossible colossi are floating in the ancient cosmos, rewriting the laws of galactic evolution. When James Webb pointed its infrared eyes toward a seemingly empty patch of sky near the Big Dipper, astronomers expected to find tiny baby galaxies. Instead, they discovered 6 massive mature star systems that shouldn't have had time to grow so large. These galactic giants contain nearly as many stars as our own Milky Way, but they formed when the universe was only 3% of its current age. Picture trying to grow a full-sized oak tree in just 3 months. That's essentially what these galaxies achieved on a cosmic scale. Star formation takes time. Yet, these 6 systems somehow fast-tracked their development. The discovery happened almost by accident. Astrophysicist Erica Nelson was examining postage stamp-sized sections of Webb's deep field images when she spotted several fuzzy red dots that looked impossibly bright. These objects were both ancient and blindingly luminous, a combination that defied explanation. Each of these monster galaxies contains between 10 billion and 100 billion stars. To reach such sizes so quickly, they would have needed to form hundreds of new stars every single year. Our Milky Way, by comparison, creates only about 2 new stars annually. The team has informally nicknamed these objects universe breakers because they threaten to break our understanding of how cosmic structures form. They suggest that the early universe was capable of a complexity that cosmologists never imagined. The naked black hole, a monster with a mass of 50 million suns, is wandering through space completely alone, rewriting the history of the cosmos. Deep in the early universe, James Webb discovered something that shouldn't exist. A supermassive black hole with virtually no galaxy surrounding it. It's essentially naked, drifting through space without the typical host of billions of stars. Most supermassive black holes sit at the centers of galaxies, growing together over billions of years. This cosmic wanderer, nicknamed QSON, breaks all those rules. What makes this discovery truly disturbing is the timing. QSON exists just 600 million years after the Big Bang. Traditional black hole formation requires the death of massive stars, a process that should take far longer. Roberto Miolino, the Cambridge astrophysicist who helped identify it, described the find as completely off the scale. 3 theories attempt to explain its existence, and each one is more unsettling than the last. The first suggests that some black holes form directly from the collapse of massive gas clouds. The second proposes that they grew at impossible rates. The third theory is the most disturbing. QSON might be a primordial black hole created in the universe's first seconds. If true, it means CSON has been lurking in the cosmic darkness since the very beginning. It is one of hundreds of similar objects Webb has identified, each a potential cosmic monster that defies explanation. The first light. Black holes older than the first stars are lighting up the universe, and they might have been there since the moment of creation. Scientists have long assumed that supermassive black holes formed after the first stars collapsed, but James Webb has found evidence of them existing when the universe was barely 400 million years old. Far too early for this process to work. Andrea Ferrara and his team at the Scuola Normale Superiore in Pisa, Italy, propose a radical solution. What if black holes, not stars, were the first significant sources of light? These hypothetical primordial black holes would have emerged from extreme density fluctuations less than 5 seconds after the Big Bang. The evidence Webb has gathered supports this bizarre scenario. Many of the bright objects in the early universe appear point-like rather than extended, suggesting they're powered by compact sources. When gas gets near a black hole, it heats up and emits brilliant light, which can look almost identical to starlight from a distance. If this theory is correct, it means primordial black holes were feeding on the universe's first gas clouds, growing larger while lighting up the cosmos. They had a head start of hundreds of millions of years. This raises even more disturbing questions. If primordial black holes were common, they might still be out there today, invisible and undetected, wandering through our own galaxy, the Infinity Galaxy. 2 galaxies are crashing together in a cosmic train wreck that's creating physics we've never seen before. Nicknamed the Infinity Galaxy, this cosmic oddity displays 2 compact red nuclei surrounded by glowing rings, creating a perfect figure 8 pattern. But its unusual appearance was just the beginning. The Infinity Galaxy formed when 2 massive disk galaxies collided head-on. What makes this collision truly bizarre is the location of its supermassive black hole. It sits directly between the two galactic nuclei, suspended in a vast expanse of glowing gas. This positioning should be gravitationally unstable. Peter Van Dukem and Gabriel Brammer, the astronomers who discovered the system, believe they're witnessing something called direct collapse black hole formation. When the two galaxies crashed, they created enormous streams of gas that became so dense they collapsed directly into a black hole without ever forming stars. This direct collapse mechanism could explain how Webb has found supermassive black holes that are far too massive for their age. They can reach enormous sizes much more quickly than traditional models allow. Jupiter mass binary objects, jumbos. Hundreds of orphaned worlds are drifting through space in pairs, and they're broadcasting radio signals that shouldn't exist. James Webb has identified over 500 free-floating planets in the Orion Nebula that don't orbit any star. These cosmic wanderers, each roughly the size of Jupiter, have been ejected from their original solar systems. What makes them truly bizarre is that many of them travel in pairs orbiting each other. Scientists call these paired wanderers Jupiter mass binary objects, or JUMBOS. They challenge every theory of planet formation we've developed. The gravitational dance required to create binary planets should be incredibly rare. Yet Webb has found dozens of these cosmic couples. The mystery deepened when astronomers pointed radio telescopes at them. Several jumbos are emitting radio signals with patterns never seen before, producing gigahertz frequency radio bursts. On Earth, signals at these frequencies come from technological sources or extremely energetic phenomena. Finding them coming from rogue planets suggests these worlds are experiencing physical processes that don't exist in our solar system. The jumbos are essentially giant electrical generators powered by their frenzied orbital dance, a world without water. A young star system is defying the basic rules of planet formation by creating worlds made of the wrong materials. In the star-forming region known as NGC 6357, James Webb discovered a planet-forming disk around the star XUE1 that contains almost no water, but is rich in carbon dioxide, exactly where Earth-like planets should be forming. This finding shatters one of the most fundamental assumptions about how rocky planets develop. Every model assumes that these regions should be dominated by water, ice, and silicate minerals. The disk around XUE1 throws all these assumptions into chaos. Water is so scarce that it's barely detectable. This discovery challenges everything we understand about planetary chemistry. A planet forming in this system would develop under completely different conditions, potentially creating types of worlds that have no analog in our solar system. Either intense ultraviolet radiation has sterilized the disk, or unusual conditions in the dust grains have led to a carbon dioxide dominance. The galaxy could be filled with dry carbon dioxide, rich planets hostile to the chemistry we associate with life. The hell planet world, so close to its star that its surface glows like molten metal, somehow maintains an atmosphere that defies every law of planetary science. 55 Canry orbits its star so closely that a full year is just 18 Earth hours. This hell planet is tidally locked with a day side hot enough to melt copper and a night side plunged into eternal darkness. Surface temperatures reach over 4,000 degrees F. By every rule, this world should have lost its atmosphere billions of years ago. Yet, James Webb discovered something impossible. This planet not only has an atmosphere, but it's rich in carbon monoxide and carbon dioxide. Something is blocking and redistributing the star's heat. This creates one of the most extreme weather systems ever witnessed. With winds howling at thousands of miles an hour, carrying vaporized rock and metal. Researchers believe this is a secondary atmosphere, continuously bubbling up from the planet's interior. The intense heat is literally cooking the planet, causing carbon-rich materials deep underground to vaporize and escape. Rock vapor rises, gets blown around by supersonic winds, condenses on the night side, and rains back down as liquid metal and stone. An ancient visitor, an ancient comet from another star system, is racing through our solar system. And it's older than Earth, the Sun, and everything we call home. Comet 3. IATL appears unremarkable at first glance, but James Webb's detailed analysis revealed something impossible. This interstellar visitor is approximately 7 billion years old, making it 3 billion years older than our entire solar system. It came from the Milky Way's thick disk, a region filled with ancient stars. This cosmic wanderer has been drifting through interstellar space since before the sun was even a glimmer in a stellar nursery. Its coma is dominated by carbon dioxide rather than water vapor, providing clues about the chemical environment where it formed. What makes this ancient visitor truly unsettling is what it represents. 3. IATL. AS is a messenger from a time when the universe was radically different. It formed around a star that lived and died billions of years before our sun existed, surviving the violent death of its parent star. For 3 billion years, it traveled through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient era. The fact that we're seeing it now raises disturbing questions about how many other ancient visitors might be passing through undetected. Little red dots. 300 mysterious objects are glowing in the early universe, and astronomers can't figure out what they are. James Webb's deep surveys have uncovered a new population of cosmic objects that don't fit into any known category. These little red dots appear as tiny crimson pinpricks of light scattered throughout images of the early universe. But their properties are so unusual that scientists are struggling to classify them. Each one is far brighter than it should be. In astronomy, red light usually indicates either great distance or cool temperatures. These objects are definitely distant, existing when the universe was less than 1 billion years old. But they're also incredibly luminous. They're producing enormous amounts of energy through unknown processes. The most disturbing possibility is that these objects represent a completely unknown phase of cosmic evolution. During the universe's first 1 billion years, physical conditions were drastically different. Perhaps these conditions allowed for types of object formation that can't happen in the modern universe. The sheer number of these mysterious objects suggests that our understanding of the universe's youth is fundamentally incomplete. The cosmic choreography galaxies across vast regions of space are spinning in synchronized patterns that suggest the universe might have been born rotating. In what may be James Webb's most mind-bending discovery, astronomers have found evidence that galaxies separated by millions of light years are rotating in coordinated patterns. This cosmic choreography defies our understanding of how structure forms. The discovery emerged from observations of 263 galaxies. Galaxies that are far too distant to have any gravitational influence on each other are spinning in similar directions. Think of it like discovering that every windmill across a continent is turning in the same direction, despite no coordinating wind pattern. Leo Shamir, the computer scientist who led the analysis, identified 2 possible explanations, and both are deeply unsettling. The first is that the universe was born rotating. If the Big Bang itself had angular momentum, it could have imprinted a preferred rotational direction on cosmic structure. This aligns with black hole cosmology, a theory suggesting our entire observable universe might be the interior of a massive black hole. The second explanation is even more disturbing. If the universe wasn't born rotating, then some unknown force or field must be operating on scales larger than anything previously considered. A rotating universe would have different physical properties than the cosmos described by standard models, creating asymmetries in physical laws that could affect everything from particle physics to the ultimate fate of the universe. The feeding frenzy. A black hole in the early universe is devouring matter 40 times faster than the laws of physics allow, and it's growing at an impossible rate. Hidden among thousands of X-ray sources, James Webb identified a supermassive black hole that's breaking fundamental rules. Every black hole has an Eddington limit, the maximum rate at which it can accrete matter without radiation pressure, blowing its food away. This object is somehow drinking from 40 fire hoses simultaneously. The discovery required a combination of Webb's infrared sensitivity and data from NASA's Chandra X-ray Observatory. The black hole appears to be undergoing a feeding episode, consuming enormous amounts of matter in a relatively brief cosmic time span. The object exists just 5 billion years after the Big Bang. Its extreme feeding rate provides a potential solution to the cosmic timing problem of how such massive black holes grew so quickly. These are not gradual processes, but violent consumption events that can increase a black hole's mass by enormous factors in cosmic blinks. Sleeping Beauty galaxies. Massive galaxies are sitting dead and silent in regions of space where they should be blazing with star formation, and astronomers can't explain why they stopped growing. James Webb has discovered what researchers are calling Sleeping Beauty galaxies scattered throughout the early universe. Massive star systems that mysteriously shut down their star formation when they should have been in their most active phase. During this period of the universe's history, conditions were ideal for rapid star formation. Most galaxies from this era should be blazing with the light of newly formed stars. Instead, Webb found numerous massive galaxies that appear to have fallen into cosmic hibernation. They contain stellar masses comparable to our Milky Way, but show none of the expected vigorous star formation. The Sleeping Beauty nickname comes from their dormant state during what should have been their most active period. Like the fairy tale princess, these galaxies stopped growing at the height of their development. But unlike the fairy tale, there's no obvious explanation. Several theories exist, but none fully match the data. The most disturbing possibility is that they encountered some unknown process that doesn't exist in the modern universe. The metallic rain world. A rogue planet drifting through space has developed the most bizarre atmosphere ever discovered, with separate cloud layers made of iron and magnesium minerals. SJ-0136 is unlike any world in our solar system. This cosmic wanderer doesn't orbit a star, but instead drifts freely through the galaxy. James Webb's detailed atmospheric analysis revealed something unprecedented. This rogue planet has a layered atmosphere where iron rain falls through clouds made of magnesium minerals. Near the surface, a dense layer of iron clouds creates weather patterns where vaporized metal condenses and falls as liquid iron rain. Higher in the atmosphere, a second cloud layer composed of forsterite, a magnesium-rich mineral, creates an entirely different weather system. But the most mysterious aspect comes from high above both cloud layers, where Webb detected hotspots. These are regions of intense heat, powered by radio auroras, electromagnetic phenomena similar to Earth's northern lights, but operating at lethal energy levels. SIMP J0136 somehow developed and maintained this elaborate atmosphere while drifting through the cold emptiness of interstellar space. The cosmic owl, a bizarre galaxy shaped like a cosmic owl, is swimming through deep space, revealing tentacled structures that suggest violent interactions we've never seen before. When James Webb captured images of the cosmic owl, they focused on its distinctive appearance with a bright central region creating the illusion of two glowing eyes. But detailed analysis revealed something far more alien. The cosmic owl is a jellyfish galaxy, a system that appears to be swimming through space with long tentacles of gas and stars streaming behind it. These tentacles are evidence of a violent process called ram pressure. Stripping, where its motion through the hot gas filling a galaxy cluster creates a cosmic headwind that literally blows away parts of the galaxy's structure. Webb's infrared vision revealed the true extent of this violence. The galaxy's tentacles stretch for hundreds of thousands of light years, containing billions of stars ripped away from their original homes. This suggests that the cosmic web, the large-scale structure of matter, is more violent and turbulent than scientists realized. Instead of galaxies moving serenely through empty space, they're fighting their way through environments that can literally tear them apart. Impossible chemistry. Young stars are creating heavy elements that shouldn't exist yet, forging cosmic chemistry that defies our understanding of stellar evolution. James Webb has discovered young star systems producing heavy elements like oxygen, carbon, and nitrogen at levels that should be impossible given their age. According to every model, this process requires billions of years and successive generations of stars. The mystery centers on metallicity, the astronomical term for elements heavier than hydrogen and helium. The first generation of stars made almost entirely of these light elements should have died and enriched their surroundings, allowing the next generation to form with slightly more complex chemistry. Webb has found star systems that appear to have skipped several steps. Young galaxies that formed when the universe was less than 1 billion years old show metallicity levels that should require multiple generations of stellar evolution. The most extreme example comes from the galaxy Jade's GS-Z 13-0, observed just 330 million years after the Big Bang. This impossible chemistry forces scientists to reconsider fundamental assumptions. Either the first stars were far more massive and short-lived than predicted, or some entirely unknown process was enriching the early universe with complex chemistry. The vanishing planet, a world orbiting our nearest stellar neighbor, keeps appearing and disappearing in Webb's observations, and astronomers can't figure out why it exists at all in what researchers are calling a highly significant finding. The telescope detected a giant planet orbiting Alpha Centauri A, our closest sun-like star, only to lose track of it completely during follow-up observations. This cosmic vanishing act has created a baffling mystery. The planet, tentatively designated Alpha Centauri ABB, appeared in initial observations as a thermal signature consistent with a Neptune-sized world orbiting within the habitable zone. But when astronomers attempted to confirm the detection, the planet simply wasn't there. Several explanations have been proposed. The first suggests the planet has an extremely elliptical orbit, making it detectable only during brief periods. The second is that it might be surrounded by a variable dust cloud that periodically obscures it. A third possibility is that the thermal signature represents a world that is still forming. The most disturbing explanation is that Webb detected something that isn't a planet at all, but a previously unknown type of cosmic phenomenon. Brain-like magnetic fields. Primordial magnetic fields discovered throughout the cosmic web are as complex as human brain networks, and they're older than any known structure in the universe. James Webb has detected compelling evidence of magnetic fields stretching across the largest structures in the cosmos, creating patterns of interconnection that eerily resemble the neural networks found in human brains. The astonishing discovery emerged from observations of the cosmic web, the vast network of gaseous filaments connecting galaxies. Webb found that these filaments are laced with magnetic fields of extraordinary complexity. The geometric patterns show a level of organization that shouldn't exist in the early universe, with nodes, connections, and hierarchical structures that mirror the sophisticated topology of biological neural networks. Standard models assume that magnetic fields develop slowly. The primordial fields Webb discovered appear to significantly predate this process entirely. The brain-like patterns indicate that the universe developed organizational complexity far earlier than scientists ever believed possible. Instead of simple gravitational collapse, the early cosmos might have functioned more like a vast cosmic information processing system. The heartbeat of Sagittarius, a star, a supermassive black hole at the center of our galaxy, is pulsing with irregular rhythms that suggest unknown physics operating at the edge of space-time. Sagittarius, a star, the 4 million solar mass black hole at the Milky Way center, has long surprised astronomers. But James Webb's continuous monitoring revealed something unprecedented. The cosmic monster exhibits erratic brightness fluctuations that resemble a heartbeat with no discernible pattern. Using its near-infrared camera, researchers observed Sagittarius A star and discovered a black hole in constant flux, with its accretion disk producing a chaotic series of brightness changes punctuated by sudden dramatic flares. These flares appear completely random, defying every attempt to find underlying patterns. Farhad Yusuf Zadi, the Northwestern University professor leading the research, described the behavior as unlike anything previously observed. Two mechanisms appear to be at play. Short-term fluctuations likely result from turbulence in the accretion disk, but the larger flares suggest something more dramatic, possibly entire chunks of matter crossing the black hole's photon sphere, the region where light itself begins to orbit. The chaotic nature suggests that quantum effects might be playing a role near the event horizon, where the boundary between classical and quantum physics becomes blurred. Dark violence. Invisible forces are reshaping cosmic structure through violent processes that leave galaxies shredded and scattered across millions of light years. James Webb has uncovered evidence that dark matter, the mysterious substance comprising 85% of all matter, participates in violent interactions that can tear apart entire galaxies. These dark matter catastrophes operate through mechanisms that remain completely invisible, except for their devastating effects on normal matter. The evidence comes from Webb's observations of galaxy clusters. When these cosmic cities collide, they create some of the most energetic events in the universe. But Webb's imaging revealed that the violence extends far beyond the visible collision zones. Galaxies located millions of light years away show signs of being violently disrupted by gravitational forces that can only be explained by dark matter interactions. The telescope detected extensive streams of stars and gas connecting galaxies, the torn remnants of systems that have been gravitationally shredded. While normal matter interactions create visible fireworks, dark matter collisions produce no light, no heat, and no electromagnetic signatures. The only evidence is their gravitational effects. The scale of this destruction suggests that dark matter doesn't simply provide passive scaffolding. It actively participates in reshaping the universe. The time warp galaxy. A distant galaxy is bending space-time so severely that it appears in multiple locations, simultaneously creating gravitational effects that challenge our understanding of general relativity. James Webb discovered a galaxy so massive that its gravitational field creates multiple images of itself across the cosmic sky. each showing the same star system at different points in its evolution. This extreme, strong gravitational lensing occurs when an object's gravity bends the fabric of space-time like a cosmic magnifying glass. Webb detected at least 4 separate images of the same background galaxy. The gravitational field is so powerful that light takes different amounts of time to travel along each curved path. This means astronomers are essentially watching the same galaxy's history unfold in multiple versions simultaneously. What makes this truly disturbing is the implied mass distribution. To create such extreme space-time curvature, the galaxy must contain dark matter concentrations far denser than current models predict. The lensing galaxy has created a cosmic time machine that displays stellar evolution across multiple epochs, revealing how massive objects can literally reshape the geometry of space and time. Stellar cannibalism. Stars throughout the universe are devouring their companions and feeding frenzies so violent they create entirely new types of cosmic explosions. James Webb has captured direct evidence of stellar cannibalism, revealing that binary star systems often end in catastrophic episodes where one star literally consumes its companion. These cosmic feeding events create some of the most violent explosions in the universe. The process begins when 2 stars orbit closely, and the more massive star gradually strips material from its companion. What starts as a gradual feeding can suddenly accelerate into a catastrophic event. Webb's infrared vision has revealed these stellar feeding frenzies in unprecedented detail, peering through the gas and dust that usually obscures them. The most extreme cases involve white dwarf stars, which can trigger thermonuclear explosions called Type 1a supernova. Even more violent events involve neutron stars and black holes, which create kilonova explosions that forge heavy elements like gold and platinum web. Surveys suggest that stellar cannibalism might be a fundamental driver of chemical evolution, responsible for creating and distributing many of the elements essential for planet formation and potentially life. Cracks in space-time evidence is mounting that reality itself breaks down at cosmic scales, revealing fundamental cracks in the fabric of space-time that challenge our most basic understanding of physics. James Webb's most disturbing discovery might not be a single object, but the accumulating evidence that space-time itself becomes unstable under extreme conditions. The telescope has detected gravitational anomalies and unexplained energy signatures that suggest the smooth fabric of space-time is more fragile than anyone imagined. Gravitational lensing effects around some massive objects show small but persistent deviations from general relativity's predictions. These anomalies appear near black holes and in galaxy cluster cores. Perhaps most unsettling are Webb's observations of what astronomers call cosmic strings, hypothetical one-dimensional defects in space-time. If they exist, they represent fundamental cracks in reality itself. Webb has also found evidence of vacuum decay events, where the quantum vacuum appears to have transitioned to lower energy states. The accumulating evidence suggests that the universe operates closer to the edge of physical stability than previously believed. Are we living in a black hole? The coordinated rotation of galaxies and the strange behavior of cosmic expansion suggest we might be living inside a black hole within a larger universe. This terrifying possibility, known as black hole cosmology, explains several of Webb's most puzzling observations. The evidence begins with the coordinated galaxy rotation patterns. This phenomenon would be possible if our universe inherited the angular momentum of the parent black hole that contains us. The theory suggests that what we call the Big Bang was actually our universe crossing the event horizon of a massive black hole in a higher dimensional space. From our perspective, This crossing appears as cosmic expansion. This scenario explains the accelerating expansion of space we attribute to dark energy. As we fall deeper into the parent black hole, space-time curvature increases, creating the illusion of acceleration. If black hole cosmology is correct, it means that everything we can observe exists within the event horizon of an incomprehensibly massive black hole. We would be forever separated from the larger universe that contains us, unable to communicate with anything outside our cosmic prison. The theory also suggests that black holes throughout our universe might contain entire universes of their own, creating a nested hierarchy of cosmic structures, a new reality. The discoveries James Webb has made don't just challenge our understanding of the cosmos. They fundamentally alter what it means to be human in a universe far stranger and more dangerous than we ever imagined. Every assumption we've made about our cosmic environment has been shattered. We thought we understood how galaxies form, how black holes grow, and how the universe expands. Instead, we've discovered that space is filled with impossible objects and violent processes. The universe Webb reveals is not the orderly, predictable cosmos described in textbooks. It's a realm where the very fabric of space-time might be unstable. We're not living in a cosmic garden designed for life, but in a violent arena where reality itself can break down. Perhaps most unsettling is what these discoveries suggest about our cosmic isolation. If we are living inside a black hole, then we are forever cut off from whatever larger reality contains us. The rapid pace of discovery has also revealed how little we actually know. If we've been this wrong about fundamental cosmic processes, what else have we missed? But Webb's revelations also offer hope. The universe's capacity for surprise suggests that cosmic evolution might be far richer and more diverse than our models predict. The telescope has essentially revealed that we are cosmic infants living in a universe that operates according to rules we are only beginning to glimpse. Perhaps most importantly, Webb's discoveries remind us that the universe doesn't owe us comprehensibility. Reality operates according to its own logic. Our survival depends on our ability to adapt our understanding to match the cosmos as it actually exists, rather than as we wish it were. The universe James Webb has revealed is strange, violent, and often incomprehensible. But it's also the only reality we have, and understanding it, no matter how disturbing, represents our best hope for navigating the cosmic future that awaits.